Hey everybody, welcome to Dry Falls State Park. We're in north central Washington at one of the most famous sites to study the geology of Washington. This is the premier location to get a sense of the scale of the Ice Age floods that came flowing through north central Washington and all of eastern Washington for that matter. Where are we located? We're 30 miles south of Grand Coulee Dam near the little town of Coulee City, right over there. And we're north of Moses Lake about an hour on Interstate 90. People have been stopping here and appreciating this view that kind of looks like the Grand Canyon. Is it simply a Grand Canyon story where a river has been cutting down into the earth? The answer is no, absolutely not. Ice Age floods, a much more dramatic story, is responsible for all that you see. And the real goal for us here is to grasp the scale of the water, the speed of the water, the volume of the water, to not only come over Dry Falls, which used to be wet, of course, but actually haul all the rock away. We've got these gaping holes that were not there before the Ice Age flood story. Now, the state park system in Washington recognized the importance of this site, and they constructed the Vista House here in 1928, and the current modern visitor center in 1966. Thousands of visitors every month trying to get a feeling for what happened here.
After decades of careful research by field geologists, it's now clear that this part of the state was hit hard by dozens of floods between 17,000 and 15,000 years ago. As North America's ice sheet was slowly retreating to the north, enormous volumes of meltwater pooled along the ice front and periodically emptied as a raging torrent across eastern Washington. Glacial Lake Missoula in Montana, and the source of many of the floods, attained a depth of 2,000 vertical feet and 500 cubic miles of water. At least 40 major floods came from Montana, but there is mounting evidence that the melting ice sheet that covered northern Washington, in the Okanagan Valley for example, was another source for water. These large canyons of Sun Lake's Dry Falls State Park were created quickly by the erosive power of the floods. To understand how the floods took rock away from here, let's hike over to the base of Umatilla Rock.
This is a good look at the basalt bedrock that makes up this southern face of Umatilla Rock. We're on the downflowed side of Umatilla Rock. In fact, this basalt makes up all of Dry Falls and all of eastern Washington, really. This is 15-million-year-old rock, which means that these are lava flows that came into this area, bright orange, super hot, started to cool, and these cracks that you see running through this basalt got established 15 million years ago as the lava was cooling. That's why you see natural rock columns all through this country. Those columns are the result of these cooling cracks that are in this basalt. So this is important because we're trying to figure out why these Ice Age floods were able to carry away so much rock when they came ripping through. This is bedrock that's essentially pre-cut and ready to be hauled off by the Ice Age floods. These cooling cracks have already done the work. They've partitioned this basalt into a series of columns that in some cases are precariously clinging here to this face. So now bring the Ice Age floods water in, pluck these columns off like picking cherries off a tree. It's easy work. Up here on Umatilla Rock, we get a beautiful look at Dry Falls. Let's compare it to Niagara Falls. We know Niagara Falls is 1 mile wide, and Niagara Falls would fit into this first set of curved cliffs between the visitor center and up here on Umatilla Rock. All of Niagara Falls right there. But this is Dry Falls. And we continue our width. There's another Niagara Falls-like escarpment. And another one, and another one.
All told, the cliffs at Dry Falls are 400 feet high and 3.5 miles wide. Comparing Dry Falls to Niagara Falls is helpful, but not a perfect analogy. The cliffs here in Dry Falls are twice as high as the Niagara Falls cliffs. The Niagara River, only 15 feet of water compared to 400 feet of water cascading over a 400-foot cliff here at Dry Falls. In fact, hovering above water level during the maximum flooding time, probably just a slight depression in the surface of the water.
We're now miles from the visitor center. Check out this beautiful bench below us. You see what I see? Enormous potholes that have been drilled in to the top of a particularly stubborn lava flow, the Grand Ronde lava flows. These enormous potholes are up to 50 feet deep. And for years they were mysteries to geologists. How do you make big, beautiful circles like that have been cut into the rock? Lots of people have been out here since trying to figure that out. People who work with flood hydraulics, water dynamics. And it's now clear that when the water was hundreds of feet deep here and pouring over the lip of this cliff, the top of that stubborn lava flow was experiencing intense swirling vortices underwater, sucking rock vertically and drilling these beautiful holes, some that have actually merged together because there's been so much erosion.
So, why here? Why did the Ice Age floods come through this part of Washington? During the Ice Age, a glacier, the Okanagan Lobe, flowed down from Canada and blocked the path of the Columbia River. As a result, multiple Ice Age floods also were blocked by the ice, and the Grand Coulee began to form. With the earliest floods, the waterfall was down by Soap Lake, but with each new flood, the rim of the waterfall retreated northward 15 miles to present-day Dry Falls.
Where are we? We're downstream of Dry Falls now by a few miles. And we're trying to figure out what happened to the rock. That rock that got picked up and plucked away from Dry Falls. What happened to it? Where'd it go? Well, in this particular part of the coulee, we're not dropping the rock yet. The water is moving at maximum velocity, maximum flood velocity. In fact, that wall is 900 feet high, and the high point of the water at maximum flood stage, 600 feet of water. 2/3 the way up that wall, we've got water traveling 65 miles an hour down the lower Grand Coulee. We're still doing erosion here. That wall is so sheer that the floodwaters had the ability to rip off the face of many of those ridges. In fact, there's a whole series of nice hanging valleys up high on the top of this wall. What do I mean, hanging valleys? Hanging valleys are these little side streams that should be gradually working their way down to the floor of this coulee, but instead they're not. They're hanging, they're suspended. They're stranded up high because of this Ice Age flood erosion. Okay, fine, so we still haven't answered the question then. Where are we actually going to drop these rocks? This is a good spot to see the little town of Soap Lake, Washington, which is important to us because Soap Lake, there in the distance, marks the end of the line for the Grand Coulee system. More specifically, the floodwaters are barreling at maximum speed down to Soap Lake, and then suddenly the floodwaters slow down drastically. Why? Because the coulee ends and we enter a broad basin called the Quincy Basin. As the floodwaters spread out and expand, they're going to drop most of their bedload or their big rocks. So here's a good example of what we're looking for. We're looking for rocks now that were dropped by the Ice Age floods. We're still down here at the lower Grand Coulee. Check this out. Look at the size of this thing. This is a beautiful flood erratic, and we're sure that the floods dropped this thing here for a couple of reasons. One, the size is kind of out of place. But more importantly, the rock type here is granite. Behind me is that beautiful cliff. That's not granite, right? That's the basalt that we know is the local bedrock. And yet, how do you explain a granite boulder this size sitting right here? And there's a bunch of them. Here's another one. I just spent 10 minutes walking around here, around this boulder, and I found 15 of these granites. In fact, this whole blonde hill here is a flood bar. It's a pile of rocks that the floodwaters dropped. So why here? Well, we're kind of in the side of the channel. The water's slowing down. And as the water slows down, it starts dropping stuff that it's carrying. You want boulders? We got boulders for you. More than a couple, wouldn't you say? My goodness sakes, look at this field. This is the Ephrata fan. We're just south of Soap Lake. The lower Grand Coulee on the horizon there. Water coming straight at you, 65 miles an hour, and then suddenly spreading out and dropping its velocity, and therefore dropping its bed load, dropping these boulders. Thousands and thousands of boulders. It's not just the surface, by the way. You can drill 130 feet into this fan and keep finding boulders. This is a pile of marbles 130 feet high, all coming from the lower Grand Coulee. You see most of them are basalt, the dark brown, but we've also got some pretty impressive granites here. And those light-colored granites, these light-colored boulders, traveled at least 40 miles over dry falls from Grand Coulee country, dropping down here on the Ephrata fan.
The cliffs and canyons of Dry Falls are just a portion of the ancient story to be told here. The lower Grand Coulee and the boulder field on the Ephrata fan all contribute to our understanding and appreciation of the Ice Age floods that poured over Dry Falls so long ago.
Funding for this series is made possible in part by the Donna J. and Charles T. Cole Charitable Foundation and by the Department of Geological Sciences at Central Washington University.